Okay, on page 137 of the worksheet packet under the math review, I'm going to do a couple of these conversions using dimensional analysis for those of y'all who may be uncomfortable and need a little bit more practice. So let's look at problem number H. Problem number H wants to take 9.55 times 10 to the 7 hertz and convert that to megahertz. One thing that you definitely have to know is your conversion factors and your exponents for each of the different prefixes. In the particular case of mega, mega's prefix is 10 to the 6. That means that it's going to take 1 times 10 to the 6 hertz to make 1 megahertz. So, what does that look like in dimensional analysis? Well, we're going to have 9.55 times 10 to the 7 hertz. We must make our dimensional analysis box. And remember, our units that's canceling are going to be on the bottom. Our units that we're interested in are going to be on top of the adjacent box. And since this is a one-step conversion, we know that 1 times 10 to the 6 hertz are in 1 megahertz. Without going to the calculator again, I hope that you're comfortable in doing this and realizing that when you are dividing scientific notation, you are subtracting the exponents from one another. So the denominator exponent gets subtracted from the numerator exponent, which means that we have 7 minus 6, which means that our answer is going to be 9.55 times 10 to the positive 1. And we must not forget our units, megahertz. So without a calculator, we should be getting comfortable and having good enough math intuition and understanding our rules of exponents and scientific notation to be able to put this into megahertz. Now, you could also report this as 95.5 megahertz, and that will also be correct. But make sure that you get your conversion factor correct and your setup correct, and that you can cancel units on top and bottom. And as you can see, we've canceled hertz, and left us with megahertz. All right, let's move on to another conversion. Let's look at G. G gives us 45,000 picometers, PM, and we want to convert that to micrometers, or microns. First thing we need to know is our exponents. Pico is 10 to the minus 12, and micro is 10 to the minus 6. I suggest starting out to convert and do a multi-step conversion by converting back to meters first, and then once you get more comfortable, then you can do it in one step. So let's start with the value of interest, 45,000 picometers. Let's make our dimensional analysis. We know that picometers is on the bottom. We know that regular meters is on the top, And we have the conversion factor for pico to micro. We know that in every 1 picometer, there's 1 times 10 to the negative 12 meters. And then, for every 1 meter, there's 1 times 10 to the positive 6 micrometers. We have our ones on the bottom, so we do not have to deal with division. And if we remember our rules of multiplication of scientific notation, we know that multiplication means that we add the exponents. And in this case, a negative 12 plus a positive 6 will give us a negative 6, which means that our reported value then would be 45000 times 10 to the negative 6 micrometers. The more standard way to do this would be to look at what does it look like if we move the decimal place 6 times to the left. 1, 2, 3, 4, 5, and one more, 6. We have to input a 0 here. Therefore, we could report this as 0.45 micrometers. Put your 0 up front. So this is two conversions, one from the base unit to a larger or smaller unit in part H, and then in G, we went from a smaller unit to a larger unit, and we went through the base first.